Hello, and welcome to our quick walkthrough of the GitHub data for OpenShift Origins notebook that we're using as part of the AI for CI project. So the overarching goal of this work is to analyze the OpenShift CI process, and that is comprised of many different data sets, and one of them obviously is the GitHub data, more specifically the PR data that represents the changes in the code base over time. So this notebook quickly gives you a introduction on how to access the available data, and then we'll give it a quick example to how to go about analyzing it. So first we start with collecting the data, and unlike some of the other notebooks in this project, we're not actually going to be collecting the data from GitHub directly here or using the GitHub API, but that's only due to the fact that there is another project that on the Thoth team that they're developing that actually goes and collects the GitHub data for some other open source projects and stores it in Ceph. So we'll be relying primarily on the data already stored for us in Ceph instead of scraping the data directly ourselves. But cool, so let's get started. We can go ahead and import all the necessary packages. And we'll go ahead and set all of our environment variables that we need to kind of interact with Ceph. And again, I encourage everyone to use a .env file to manage all of their keys and all of that. We'll then go ahead and collect the data from Ceph. So you can see here, it's downloading the data now. Now that we have it, we can go ahead and take a look at the head here, make sure everything looks good. This appears reasonable. But let's go ahead and actually introspect just one row here and see what the schema of this data is. Cool, so we can see we have about 15 features here. We have title, body, size, a couple of different timestamps, a couple different user types. These are all single valued features, and then we have a couple of these additional collections at the bottom here. Cool, so that's great. We can see already though that like title is text, body is text, size is a category, a categorical variable, created by is username, created at is a timestamp. So we have a number of different data types that we're going to have to deal with, which is fine. Great, and then we have, if we want to kind of unroll some of these collections and see what they contain, we have interactions, looks like usernames and the number of times that each user actually touched the PR. Then we have reviews, which tells us kind of who reviewed and when they did it and what label they provided. It looks like we don't actually have the review itself, however, just the metadata around it, like the word count. Then we also have labels, which, this is a closed issue, so this is all the labels that were attached to the PR at the time of closing. And we have the commit hash, as well as the name of each of the files that was changed in that PR. Cool, great. So that is kind of the extent of the data that we have access to. I think it's all pretty interesting and ripe for analysis. So the next kind of thing you'd want to do immediately, right, is to analyze the data. But like I mentioned above, one thing that maybe was obvious to everyone is that it's not all numerical data. It's a mix of text and categories and numbers. And so there's not really like a pre-built machine learning model or statistical model, or there are many that really are designed to take such varying data types. So one way that we can address this is by doing some feature engineering and converting some of the non-numerical features into numerical ones. So I'll just give a quick example in the second half of the notebook, how we could do that and some analysis on it. And again, there are many different ways to do this. This is just kind of a quick example. So cool. So the first thing we're going to do is take the body size, so the body text, and encode it into a single number and just use the word count or the size of the text. So we'll go ahead and convert the body feature into body size, turning that into a number. We'll also take time to merge or derive time to merge as a feature. So, we have these timestamps for all of these different PRs. If you're looking at 10 or 15,000 different PRs, the actual timestamps maybe aren't that interesting, but the differences in the timestamps between opening and closing, kind of categorizing or quantifying that time that it was open is actually interesting and a comparable metric. So we'll look at time to merge. And then we'll also take changed file number, which we actually don't need to derive in any way because that's already part of the core data set. We'll make a subset of the features and start to do some analysis on that. So again, like I said, we'll just be looking at body size, time to merge, and changed file numbers and see if there's any interactions between them. So we can go ahead and run that and describe the data set. We can see kind of the mean, standard deviation, the min and max values for everything. So that's interesting. We can also go ahead and plot scatter plots for each of the kind of pairwise interactions of each of these to see if there's any anything obvious that comes out. Kind of unclear from these plots if there's any real meaningful interaction between the features. So we can also go ahead and actually get some values directly by getting the correlation of each of these. And cool. And so we can see here that there's maybe a little bit of correlation between time to merge and body size, but really not much. But again, this is just an example, and I think goes to show that there's a lot of work in feature engineering that we can do here to generate some more meaningful and insightful analysis on the PR data that we have available here. And so yeah, so I encourage anyone who's interested to contribute to this notebook and to this analysis and see if there's any additional kind of feature engineering work that can be done. But great. Otherwise, I hope this was helpful and insightful, and I look forward to seeing contributions. Thank you.